Hi guys, so I just wanted to show you the video if you of the demo if you missed the class. So here I have a circuit, but the switch is open. So the current will go from the battery here and it's gonna go through a rod. You see, it's a conductor and it can moved. And then it's going back here into the battery and the switch is open, right? So I have a closed circuit. And here I have a magnet. It's a horseshoe magnet. So the magnetic field will be here between the two poles. So when I'm going to close the switch, you're going to have the current going into the x-axis here. Let's say this is the x-axis. And then you have the magnetic field up and down in the y-axis, x, y. So you're going to have a force here in this direction, right, in the z-axis. So if everything works as supposed to, you should see the rod moving. So the current is flowing here into that conductor. Magnetic field is up and down. So you're going to have a force here, a magnetic force, because you have charges moving into that conductor. So I close and boom. Did you see it moved? It's called the Lorentz force. And sometimes it doesn't move if it's not here. It moves, right? It has to be inside the magnetic field because outside, very quickly, it's losing its magnetic field. Okay, so if I place it here, boom, see it moved. So it's a small demo, but it's still nice. The other thing I show in class, so hopefully it's, I don't know if you can see very well, but I talk in class about the speaker. So this is a speaker here. And you see the speaker has a permanent magnet here. So with a north pole and a south pole and north pole in this direction. And inside here you have an electromagnet. So when I energize the electromagnet, it's going to be pushed and pulled by the permanent magnet. And so the electromagnet is going to push and pull on that soft cone. So there is a cone here. It's like a cardboard. I don't know if you can see, but it's moving. So if the current goes back and forth at the frequency of music, for example, the electromagnet here is going to be, so electricity is going to flow in one direction, another direction in the electromagnet. So the electromagnet is going to behave like a bar magnet, north, south, and the north and the south are going to flip over at the same frequency as the music. So it's going to be pushed and pulled by the magnet here. Okay, so the permanent magnet is pushing and pulling the electromagnet depending on the direction at which the current is flowing. And it's going to push and pull the cone. That's going to make sound waves, right? So just to show you that. I don't know if you can see. You see the cone moving? It kind of makes some noise. That was all.